in polar graphing, there's a type of curve that's called a rose curve, and I'll show you. It mainly has the form y equals a sine of bx or a cosine of bx. Sometimes you could throw in a plus c there also. So let's see what these are all about. This is a pretty short video actually, but it is a little bit confusing. So here's y equals 3 sine 2x. And let's just take a look at what happens here. If it was just 3 sine x, it would be a circle. But this time it's not going to be a circle. Let's just get a feel. So this point here is 0, 0. That is over there. This point here is 90, 0. Because if it's y equals 2x, it has 2 full cycles at 360. So here's 360, 180. So 90, 0 is right in the middle also. Now, this part can be a little bit confusing. A point that's important is right here, this green point. That's at 45, comma 3. So that's like here. So somehow, I'm going to go like green, sorry, red, and then it turns green like that. So that's what it looks like on the rectangular graph. But on the polar graph, and this part can be a little bit confusing, it has to sort of spiral towards the green, and then once it hits that green point, it has to spiral back to 0. So it ends up becoming like the petal of a flower, right? Because x-intercepts turn into points at the pole. So here it's like a loop. Now there are a lot of different loops I can make, but the way this loop goes, because it's 0 here and 90 there, this loop is kind of like fits right between that L shape. In fact, I could even draw that a little more accurately by kind of making a sort of tangent, at least in the beginning. So that's what it looks like. Because they could be a skinnier petal, but we'll see what happens, because this actually gets pretty confusing right now, because my next point is down here. That's at 135, negative 3. So 135 is in this is going this way, but it's negative, so the point ends up over here. So that's kind of strange. I'm going to put some arrows on if what happened if this got graphed, then that. Now to really see what's happening, I need to look at this blue line. This blue line is from 90 to 135. So at like 91 degrees, I'm kind of facing in this direction, but I'm graphing a negative value, so I'm coming backwards. And then as I sort of go here, this starts to happen. And I end up with that. So that's actually the third thing. So it goes like this: 1, 2. You don't have to write these numbers. I'm just showing you 3. And then from here to here, see now it's going from 135 to 180. So I'm facing in like this direction, but I'm going backwards because it's negative. So I end up like that. So these two petals here on the right correspond to the sort of first cycle of this, or half of this sine curve, or at least one going from a starting point to the next starting point. Now I'm at 180, and I'll say I'm 180, so I'm back to the center. Now eventually I'm going to get here to 270, 0, so I'll be back to the center there. Also, somehow I have to get from here to here. Well, anything that has this sort of parabola shape, and I'm just going to make another red and green one, anything that has this parabola shape where we have these x-intercepts is going to turn into a petal-looking thing on this curve. But see, I'm at 180, so I'm facing, I'm going to make it red, I'm facing in this, like I go to 180, 181 degrees, I'm facing in this direction. So my next, let me make this, this point right here is pretty important. That's 225, comma 3, which is over there. But the order that this happens, we're back to being positive, so 180 is like facing in this direction, so this is going to go like that. And then it's going to turn around, because now it's getting smaller, closer to 0. So this was the 5th thing made, and this was the 6th thing made. And now, it does have to get back to this point over here. And this part is negative, so that does get a little bit confusing. A good point to look at is this one right here. This is 180. That's two, so this is 315 over here. But it's 315 negative 3, so if I'm pointing in this direction, and then I go negative 3, I end up over here. Now this blue line, I'm facing 270, 271, things like that, so I'm kind of facing like in this direction, but I'm going backwards because it's negative, and that's why the next petal goes like that. So that's my 7th thing. And finally I end up with that as my 8th. So we get this 4-petaled flower looking thing, rose curve, but the order is very surprising. Like on a test I could ask you, what order did these petals get drawn in? And the answer is this one got drawn, then this one, 1, 2, 3, 4, then this one, and finally this one. If you graph on a graphing calculator in kind of slow motion, you would see that that's the order that it happens in. Okay, so that's our first example. There's only 3 examples in this. Okay, the second example is I have this time y equals 3 sine, I have a bigger number here, 6 theta. So actually 6 curves happen in a period of 360 degrees. 1, 2, 3, 4. 1, 2, 3, 4, 5. Oops. That's the 6th one. That's the 360. And without doing this one like every single detail of it, what I want you to notice is that these sort of top things, each of those sort of parabola things has x-intercepts, which makes each of these become like a petal, because if it starts at this point, it corresponds to the pole, and this point also corresponds to the pole. So I really want to concentrate on this first thing. It's going to make a petal. Why don't I make one part? Each of these things is 60 degrees, so this petal here would have a peak at 15 degrees. So 15 degrees, comma 3 is 1, somewhere over there. Now drawing the petal, the trick to drawing the petal is that this is between 0 and 30. So a good thing to do is to draw like a horizontal line at 0 and 30 and make my petal stay between those 2 lines. So that's our first petal. Now I'll put arrows on these. Now I'm going to jump ahead. Actually, I'll do the second petal. Make that green. and that yellow to get a feel for this. This yellow point is right here. So the whole curve is 60. So this is the part from 30 to 60. And I'll even make this line here. So this second petal is going to fit between 30 and 60. But because these are negative, it's going to be in this part right here. So this green thing, which goes like 31 and negative, if I was at 31 pointing this way and went negative, it would go like that. And then over here, I'm from 45 to 60. I'm pointing in this direction after 45, but I'm going backwards, so it causes it to go that way. And those are the first 4 pieces. My next one is positive again. This one is between 60 and 120, but this portion here is between 60 and 90. So my next petal is going to be between 60 and 90. I'm just going to make it red. It's going to look like that. And then my next one's going to be an upside down petal between 90 and 135. Sorry, yeah. Just going to make all these dotted lines every 30 degrees. So our next one's going to end up, we're basically facing in this direction, but we're going negative, so that's going to happen. Then I'm facing in this direction, but I'm going positive. Then I'm facing in this direction, but I'm going negative. And what ends up happening when it's all done is I end up with 12 petals, although I don't think I drew this very well. 1, 2, 3, this one's going to end up here. 4, 5, 6, 7, 8, 9, 10, 11, something like that. So we get this 12 petal thing. Half of them were these 6, and then half of them were going that way. And it is pretty confusing. There's some GeoGebra sketches that help you really see and watch the points as they kind of move along. These red ones are kind of every other one, and the yellow ones are also the other ones. Anyway, I didn't do a very good job explaining this, but I will, if you're in my class, I'll direct you to a nice graphical web page that lets you watch both of these curves trace out. I guess what I'm getting at, though, is that the number out here is half the number of petals. So when there's a 6 there's going to be 12 petals. In this one, there was a 2 here, and there were 4 petals. Now, sometimes we throw in an extra number here, a plus b. For instance, y equals 3 sine 2x plus 1. And I find this one kind of interesting because you actually have a couple of y-intercepts here, but you also have sort of these maxes. Here, I'll make that blue. I'll make this green. So what happens here, first of all, it starts off not at 0, 0, but it starts off at 0, 0, 1, which is kind of interesting. See, there is a y-intercept down here that might be relevant, but let's just say we don't want to deal with that right now. This blue point here is, if this is 3 sine 2x, that makes this 180. So this point, oops, sorry. This point here is 180. Halfway through. I made that thing a little bit too high. Here's my middle line at plus 1. So this is at this point here was at 0. This was 45. This was 90. This was 135. This was 180. Let's just start with those. Now at this point, 45, comma 3 is going to be in the middle here. 1, 2, 3. Now, what's important here is this point, which I don't even know exactly what it is. I might be able to zoom in on it or something, but it's certainly but it's about 100. It's a little bigger than 90, but it's less than 135. So I'm going to make a dotted line there, because I have to get to this point. Let me make that point green. I have to get there, but the way I get there, I'll make this whole line green, is like that. So I don't have a whole petal because this piece didn't start at the pole. Now something to me kind of interesting happens. I'm going to extend this line a little bit because I need to go backwards. This yellow part from here, actually I'm going to make it yellow and then gray. And this point here will be a gray point. So that gray point is at 135, comma, negative, negative 2. This was at 4. So 135 negative 2 is actually somewhere over here. So what happens is, in between these two things, which were about 100 and about 165, I'll just make a little approximate thing there. I need to get my petal, this yellow part. See, I'm at 100, I'm facing in this direction, but I'm walking backwards, so this happens. And now I'm at 135 and pass. I'm facing in this direction, but I walk backwards, and that's what gets me this small petal. So I have a big petal and a small petal. Now I have this little portion, which is from about 165. Well, the way I see it is I have this I have another petal now, because now I can really see that from here to here is going to be a big petal. The very top of it is located at, is that 225? This is 90. This is 90, 180, 270. Yeah, so 225, comma 3, or 225, comma 4, sorry. I just noticed that this point was supposed to be all the way out here. Okay, so what's going to end up happening is, after this point, I don't even know exactly what it is, about 165, but now I'm facing forward, so we end up with a petal, like that. And then finally, I get under this part underneath. This ends up, I'm at like 90, 90, 180, 270. So after 270, so I'm facing in this 270 after 270 direction, but I'm going backwards. So I end up with another small petal. And it suggests that if I keep going, I'm going to fill in that. So this is pretty confusing, I am going to admit, but basically we end up with 2 big petals and 2 small petals, and the petals, the small petals correspond to this part, sort of underneath the, to this part underneath the x-axis, those are the small petals. And the big petals correspond to the parts above the x-axis. Again, this is pretty confusing, and I think that's all. It's been 20 minutes. I think that's all I want to do about them right now, just to say that when you have a coefficient in front of the theta, you end up with a lot of, instead of a circle, you end up with these sort of petals, this rose curve, and sometimes they're sort of symmetrical, like in these two, and sometimes it's not symmetrical. If you have a plus b there, it can make it not symmetrical. I'm definitely going to point you towards a GeoGebra page that lets you drag a slider around and watch both of these curves graph simultaneously, so you can really see what's going on. You can move them back and forth. You get a better feel for it. But this is just for this video, just to give you some idea of what the topic was of the day. It was rose curves.